The cause of Brownian motion is the impact of molecules of dispersion medium with the colloidal particles. Since the impact is unequal, hence the motion is of zigzag nature. It is further observed that as the size of colloidal particles increases, the movement becomes slow. This movement directly supports the kinetic theory in which it is postulated that particles are in a state of ceaseless motion. Further, since gravity has no effect on this motion, hence colloidal particles do not settle down at the bottom of the vessel and the soul becomes stable. Number 4, electrical properties. Electrophoresis. Besides Brownian moment, another reason which explains the stability of soul is the presence of charge, either positive or negative, on the colloidal particles. Of course, a soul is on the whole electrically neutral because equal and opposite charge is possessed by the dispersion medium. Thus, due to the presence of similar charge on colloidal particles, they repel each other and do not combine to form bigger particles. The following example of preparation of a soul can explain the origin of charge on colloidal particles. Consider the peptidation of freshly prepared ferric hydroxide precipitate by FeCl3 aqueous. As we have already learned, FeCl3 aqueous provides Fe3 plus and Cl minus. Out of them, Fe plus 3 are adsorbed on the surface of FeOH3 precipitate, which ultimately breaks down it into smaller particles of colloidal dimension. But due to adsorbed ferric ions, each colloidal particle becomes positively charged. Hence, it is an example of a positive soul. Of course, chloride ions remain with water, the dispersion medium. Hence, soul on the whole remains neutral. On this basis, we can understand why As2S3 soul and some metal souls like that of gold, silver and platinum are called negative souls. Now, when a As2S3 soul is taken in a U-tube, as shown below, and an electrical field is applied through two electrodes, anode and cathode, then the colloidal particles of arsenic sulfide are found to move towards the positive electrode where they are deposited as precipitate. Similarly, if we take ferric hydroxide soul, a positive soul, in the above setup in place of arsenic sulfide soul, then the colloidal particles of ferric hydroxide will move towards cathode and will be deposited there. This movement of colloidal particles towards the electrode of opposite charge under the influence of electrical field is called electrophoresis. Thus, with the help of electrophoresis, we can find out the electrical nature of the soul. Number 5, chemical properties. Here we shall discuss coagulation and protection. First of all, coagulation. Coagulation is defined as the process of aggregation of colloidal particles into a precipitate by addition of a suitable electrolyte to the sole. And the electrolyte is called coagulating agent. Thus it becomes reverse of peptidation. When a little amount of an electrolyte is added to a sole, the aggregation of colloidal particles starts. This process is called flocculation. But this can be reversed by shaking the sole. But as the concentration of electrolyte increases, aggregation becomes irreversible, which means now the colloidal substance will appear as an insoluble precipitate. This precipitate cannot be converted back into the sole by merely shaking the suspension. This precipitation is called coagulation. For example, when some FeCl3 is added to As2S3 sole, a yellow precipitate of As2S3 is obtained. The process of coagulation is explained on the basis of charge neutralization, that is, the effective ion of the coagulating agent, for example Fe3 plus ions, in the above case, neutralize the negative charge on As2S3 colloidal particles, due to which they can come closer to each other to form the precipitate. As2S3 is insoluble in water, which is the dispersion medium. Precipitation or coagulation value of an electrolyte, that is, coagulating agent. It must be noted that a certain minimum concentration of the electrolyte is needed to cause the precipitation. This is quantitatively expressed in terms of coagulation value. It is defined as the minimum amount of an electrolyte in millimoles which must be added to 1 liter of a colloidal sole so as to cause its complete coagulation.